Good morning, everyone. We are here today with Michael Matz, Gabriel Gomez, and Libor Pekacek to talk about user space live patching. And I'm really happy to have all of them here with us, and hopefully it's going to help developers to understand a little bit more about this feature and hopefully creating some interest for further contribution. So, guys, if you don't mind, would you like to introduce yourself, please? Michael, would you start?
Sure, it would be a pleasure. So I'm Michael Matz. I'm working within the SUSE Labs organization, caring mostly for upstream contributions in low-level components like the kernel and the compilers. And we are also caring for implementing the live patching infrastructure for our company. And as I'm a team lead within that organization, I'm overseeing this part as far as user space live patching is concerned.
Thank you, Michael. Libor, could you introduce yourself, please?
Hello, I'm Libor Pekacek. I'm also a member of SUSE Labs, and among other my duties, I'm the technical project manager for live patching. So my task is the integration of the technology with the SUSE products, and the project management part also includes the actual delivery of the products.
Thank you, Libor. And Gabriel, your turn now, please.
Hello. Yeah. I've been working with toolchain related things for a while now. I used to work with glibc, mostly and purely on glibc, and very recently I joined SUSE to work on the user space live patching project, and I've been mostly dealing with coding of the user space live patching per se.
Thank you, Gabriel. So, thank you, guys. Without any further ado, let's get started. And Michael, I would like to start with you with a very high-level generic question. I'm wondering if you could explain us what is the target use case for the live patching feature, and why do we actually care so much about this?
Yeah, so we are caring for this because our customers care pretty much about that. And that has two reasons, basically. So we will get later to that, to more details, but we started with kernel live patching, and there the use case is pretty obvious. There are servers, for instance, long-running servers that, due to various issues, take, for instance, a very long time to boot. So every downtime, every time the kernel needs to be patched, there's basically no way to avoid rebooting a server, and that needs the necessary time to reboot the server, and that might be too long for certain uptime guarantees that customers are willing to give to their customers. And so kernel live patching is relatively obvious. You don't want to have to reboot a server just for applying, for instance, security fix. Now, user space live patching is actually the same reason, but not for the whole machine. You don't have the issue that you don't want to reboot the whole machine, but rather you have the issue that you don't want to restart a certain application. There are two obvious classes of applications where you don't want that. One application are web servers that may contain user sessions, for instance. So as soon as you restart such a web server, the user sessions that are currently connected to it will be gone, except there are multiple ways around that in the application itself, but they are complicated to implement and possibly slow down the application. So you ideally don't want to restart such web servers, but of course you still want to have them not, for instance, vulnerable for new discovered security vulnerabilities. The other class of applications are database servers. those have the property that if they serve very large databases, their startup time is very high. So there are, for instance, in-memory databases where, I don't know, let's say 2 terabyte of data, and if that needs to be read in from disk, no matter if it's SSDs or spinning Rust, it takes a very long time until it's fully started up. You can't basically answer database queries. So you want to avoid starting database servers in the same vein as you want to avoid restarting full physical machines. So, and in both cases, that's all purely a process that you don't want to restart. And for that, you want to somehow magically change the code that is running in that process while it is running in order to be hot patchable with fixed variants of whatever issues occur. So that's the basic thing of live patching.
Okay, great. So really, it's maximizing the uptime and ensuring that services are running 24/7, basically.
Exactly.
Very nice. So I think I understand there are two different spaces. There is the user space live patching and the kernel live patching. So I would really like to understand why does the user space live patching come that late after the kernel live patching? Any technological reasons or needs? And Libor, if you could just maybe help me with that, please.
Sure. Yeah, I was involved in the kernel live patching or development of kernel live patching and its integration into SUSE products. And once we successfully delivered the live patching product with the kgraph technology by then, we looked into reusing the knowledge and experience we gained in the exercise for user space. And very quickly, we found out that it's going to be a completely different adventure. Because for kernel, all of the code is in our hands on the kernel side, and there is clear boundary between kernel and user space. So it's clear when the CPU is executing the user space code and when it's in kernel. And that helps a lot with live patching the kernel. However, for user space applications, no such clear boundary exists. So we had to adjust many of the techniques and assumptions for the new technology, and that of course takes time.
Yes, indeed. Thanks, Gabriel. Something maybe that you could help me with is if I'm a developer, right, and I have my application running in user space, can I patch my application with libpulp at all, like to take advantage of this user space live patching?
Right. So not exactly, and not currently. So the way we envision user space live patching, we want to do live patching of libraries. So you wouldn't be live patching your application. There is nothing that intrinsically blocks or prevents us from live patching a application, and we're working on that. But currently, we only do live patching of libraries. On the other hand, if your application, uses libraries, which is usually the case, then your application will be able to be live patched, but only on the libraries that it uses.
Okay, so let me ask you a follow-up question. Then to use libpulp, I have to make code changes to my libraries. Is that correct?
Not exactly. You have to make changes, but you don't have to make any changes to the code of your libraries. So the code remains intact, but you have to change the build scripts so that your libraries get linked against a object that is provided by libpulp. Also, you have to pass a different compiler option during the building of your files. It's a common option. It's been in GCC for a couple of GCC versions now, and that's it.
So, Gabriel, Michael, a follow-up question to that. Is that all I really need to have a live patchable process, or there's anything extra that the developer or system administrator will need to take care of?
Not really. So there's one thing that is missing in the picture, which is how the process is, or the application is actually started. That it becomes live patchable in the future. Currently, we are doing this with LD preload facilities of the dynamic linker, which loads the pulp library that implements the whole thing into the process. We are looking at ways to avoid that, but currently that is the way. So you would need to start processes with LD preload on the pulp, and then you have a live patchable process.
Okay, I think that explains. So on a running system instead, let's say we have everything ready and now I'm in my production environment. Can I list which processes have live patchable libraries enabled per se, so that I know what can really be done live on my system? Gabriel,
Right.
can you help me with that?
Yes, sure. So yes, there is the ULP tool. This is a tool that is provided by libpulp, and it does exactly that. It lists all the processes that fulfill those requirements that we mentioned previously. So it lists processes that have been started with the LD preload thing and that have been linked against the special object that libpulp provides. And also, apart from listing the processes that are ready to be live patchable, it also lists the state of the threads of the process. So, for instance, if a live patch have been installed in the past, the ULP tool will show you if all of the threads in that processes are actually using those installed live patches.
Okay, so I see. So each thread is independent of each other when it comes to the actual use of the live patches. Is that correct?
So, right, precisely. So in order to keep program consistency, the live patches have to be applied at certain moments. But on the other hand, we don't want to wait for all the threads in a program to be at that certain moment, because we could be waiting forever. So we take a two-steps approach to this. So we first apply the live patch in the sense that we install the new functions, the new version of the functions, by copying them into memory. And we do that regardless of the state of any of the threads. So after the functions have been loaded into memory, a global counter is updated, which conveys the information that those functions are ready to be used. But it doesn't mean that the threads are going to use that. The threads to have local counters, which they can compare against these global counter. And it is only when they are going into a library, only on library entrance, that these counters get updated.
Okay, Gabriel, so I would have a follow-up question, but how does this really help with consistency?
Okay, so well, I mentioned that these counters only get updated when going into the library, so when crossing the library boundary. And so, for instance, if you have a thread that went into the library and never returned, for instance, if it's running in a library loop, waiting for inputs, or maybe it's waiting for new connections, then it's never going to use the new versions of the live patch. It's only when it really leaves the function, when it leaves the library, that it actually is going to see the new universe. We call it universes. So think of snapshots. So a thread, if it went into a library, then it's going to use the snapshot whenever it is within the library. When it leaves the library, then it can use a different snapshot. So it never uses two different snapshots if it is within the library, making internal calls. And that kind of helps because, for instance, if you have two functions that are going to be modified by a live patch, then this could be dependent. I mean, the changes to function A could have a dependency on changes to function B. So you don't want to use just the new version of function A. You want to use the whole snapshot, and that's why this is important for consistency.
That makes a lot of sense. Thanks, Gabriel. So thank you very much, because this was, I think, a very complex mechanism that you explained. And Libor, I would ask you something about this. Having heard about the complexity of the infrastructure around the live patching and how this is really implemented, can live patching work without this complexity for this overall consistency mechanism?
A good question for a project manager. We've got to justify the costs, of course. Yes, I made a short research and saw that there are live patching technologies which do not use a consistency model or consistency checking. I believe these can work reliably on uniprocessor systems with simple patches. So, however, in that environment, when there is only one CPU, so when the CPU is executing the live patching code, we can be sure that nothing else is executing the original code, which is going to be live patched. So that's still okay. However, when we have multiple processing units in the system, so one is doing the live patching and other CPU cores are executing the code which is currently being live patched, we need something better. Maybe the simpler technologies I mentioned before just cover their eyes and push the button and hope for the best. And I believe statistically they can be successful in many cases. However, we aim for better. With the increasing number of CPUs on the system, and we've got hundreds now, and all of them executing the same piece of code. There are heavily loaded pieces of code in certain applications. We need to ensure that they do not step on each other's toes. And another benefit is that this consistency model also allows us to replace multiple interdependent functions at once. So even if there are some semantic changes or interface changes between the functions, we can do it with the advanced live patching.
Thank you, Libor. I guess then it really boils down to the complexity also of the hardware that it's being deployed these days. I mean, multi-CPU processors is pretty much the de facto standard. And consider that we're really aiming data centers as use case for this live patching, then complexity is something that we have to live with. Which I suppose there are many examples of complex things that have to be developed over time. So thank you. And I'm just sorry because you have to project manage it. Gabriel, a question for you instead. I would like to look now a little bit more on the practical side of things. And I wonder, how do I actually install a live patch? So we have all this infrastructure, we have all these tools. Now I really want to take advantage of it. What shall I do?
Okay, so LibPulp provides some tools for that. So one of the tools that it provides is the ULP trigger tool. With this tool, you use it from the command line. You give it argument as argument. You give it a live patch, a user space live patch, metadata file. And you have to give it a process ID too. And this kind of shows us that the user space live patching, it is by process. So if you have two different processes that are running the same program with different processes, then you have to patch two processes, right? Because they were there are two processes alive. And to help with that, there is also the ULP check tool, which has the same parameters as ULP trigger. It gets a ULP metadata file and a process ID, and it will tell you if the live patch has already been applied or not.
Great, thank you. Michael, can I install instead a live patch across the entire system that I have running?
Yes, of course. Obviously, as Gabriel just mentioned, to apply an individual live patch to a process is a relatively manual process, and we have the tooling, of course, to scan the whole system for processes that need live patching, and at the same time apply those live patches if they need it. So yes, there's that, and as we are also a Linux distribution vendor, we are not only having the tooling for scanning the whole system, but of course we are going to deliver the live patches as a sort of special packages to our customers. So as soon as they install such a package with the usual means in which you can install packages on your systems, then this will automatically trigger a scan of the system for all these processes, install the live patches or prepare for installation of these live patches. And then if they continue running and as soon as the moons align, then those live patches will become active in those running processes. So yeah, that's basically for a system administrator, it's relatively transparent. You just install or you update your system, you get new packages, and those automatically will apply the live patches that are associated with those. So yeah, you can.
And this is, yeah, that's great. And I suppose this is just a huge advantage when we consider like CVEs, for example, to get patches that we can offer as a distribution vendor, and those can be applied live on the system. So you take advantage of bug fixes affecting actually security bugs in a production environment without rebooting. It's
exactly,
just a huge
exactly. It's really transparent, and basically what it's the same, or we envision at least it's the same mechanism as with kernel live patches, where exactly this already happens. You do for SUSE, you do a zipper update, and then it installs new packages, and with it live patch packages, and then the kernel is patched accordingly. So without and your running system has all the CVEs fixed. And this is what our goal is also with user space live patching, and we have the tooling for that basically. Yeah,
that's cool. Libor, I want to ask you a final last question. Does the live patching expose the system maybe to malicious exploits in a easier way than what they could basically use in a system without? So is, for example, the mechanics that we have implemented, developed, offer an open door or a backdoor in this case for crackers to use? Could you touch base on that, please?
Security. That's an important topic. I do understand these concerns around security, especially in connection with new technology and new enhancements. In the era of disruptive innovation, we very often see that certain advancements come at the cost of existing functionality or even sometimes even security. We do not follow this path with live patching. In kernel live patching, we reused existing technologies in a new context. So we took ftrace and kernel module loading mechanisms for kernel live patching, plus the consistency model, and that's most of the science was. In the end, we didn't weaken the security restrictions around the existing technologies. We just leveraged them for our purpose. In user space live patching, we are doing the same. We have the LD preload mechanism, we have the dynamic library loading mechanisms, existing ones, and ptrace for patching the system. So again, we are not weakening the security restrictions associated with them. And in the end, if the user has the rights to live patch the system, the user already has the rights to do many other things. So it's the task of the IT security to give the rights only to the right people.
Yeah, I am really just very happy that basically we have been leveraging all the mechanics and all the infrastructure that already offers some security level on the system to do exactly what we are doing. So as you said, this is not something that it exposes the system to other threats, and as long as the management of the user on the system is done properly, then nothing worse can come out of it, which is really great to hear. So with that, this was really my last question on this topic. I would like to thank you, Gabriel, Michael, and Libor, for your time today. It was really a great talk, and yes, it is quite complex topic, but I really hope that developers are getting interested in what we are doing here, and that this topic can trigger much more interest, and also clarify some of the aspects around how live patching in user space work. So thank you very much, and
it was a pleasure.
Likewise, pleasure.
Thank you.
Have a lovely day, everyone, and talk to you soon.
Bye-bye.
Bye-bye.
Goodbye.